Part 1. NAC Wiring Methods. First off, we'll talk about the two NAC wiring methods. The first is known as a Class B circuit. A Class B circuit uses an end-of-line resistor, also known as EOL for short. This cable goes in and out of the NAC devices on its circuit until it reaches the last device, which is considered the end-of-line NAC device, because this is where the end-of-line resistor gets landed. The last device on this type of NAC circuit is the only device that needs an end-of-line resistor. To see how that resistor gets landed, let's take a look at this fire panel with one NAC device on its Class B circuit. Here we see how that resistor gets landed. With the NAC wire, the resistor goes across the positive and negative terminals of the NAC device. Even if there's more than one device on the circuit, the last device is terminated like this with a resistor. Why put a resistor here? What's the purpose of the resistor? The end-of-line resistor serves the purpose of circuit integrity. The panel is continuously monitoring for this resistor value. If there is an open or a short in the circuit, the panel knows to beep and display a trouble message, indicating there is an issue with the circuit. The panel will only be happy and normal if it can see the resistance value of the end-of-line resistor. That's a Class B NAC circuit in a nutshell. This is a Class A NAC circuit. This differs from the Class B circuit in a couple of ways. 1. No end-of-line resistor. 2. The last NAC device will have a wire loop incoming from the previous NAC device and outgoing straight back to the main fire alarm control panel. Without going into too much detail, we can see that a Class A circuit uses more cable than a Class B circuit would. However, it is more reliable and resilient in terms of circuit integrity. A short, ground fault, open circuit, faulty device, or cut wire will only stop the operation of the NAC devices up until that point. This is because, in the event of those issues, the voltage from the fire panel is fed into both directions of the NAC circuit. Part 2. Demonstration in the real world. So, that is roughly a way to illustrate how the wire is pulled. Let's say, for example, this guy is getting ready to pull a few units on the first floor of an apartment building. And I'm feeling nice today, so I will drill out his pathways. So he's going to pull into the first unit, room 101, and create a wire loop into the box. Then to the second unit, room 102, and pull a wire loop into that box, and so on. Now, realistically, for efficiency, the wire would be pulled straight through the rooms and looped back into the boxes, pulling slack off the spool of wire from the last device to the pulling start point, which would look a little more like this. Pulling the wire straight through the pathway, for demonstration, we'll make this room the last device with the end of line. And now this guy is going to pull wire off the wire spool towards him in the direction of the last device to create a wire loop, which would then be routed into the back box. Then he's off to the next room. And again, he's pulling the wire towards him out of the drilled holes or raceway to create slack for this device's incoming and outgoing wire. Until he reaches the pull starting point in which the cable is cut and then ran to either continue the circuit or to be routed into the panel. Pulling loops is a method of pulling cable. It's not a requirement. It's dependent on the volume of devices, what the scope of the project is, and ease of pulling. All said and done, these loops get cut and replaced with the NAC devices, which we'll see later. Part 3. NAC device wiring. NAC devices are terminated in a parallel configuration. just as the wire is pulled in a parallel configuration. Here is an example of what that looks like. We have our incoming wire and our outgoing wire to the next NAC device. We can also see that the NAC device acts as a middleman, completing the circuit where the wire was once a continuous loop. To demonstrate this, let's wire one. For example, let's assume we can see through the cable's sheathing. First, we cut the pulled loop and strip the cable. Second, we land both positive conductors to the positive terminal of the NAC device. Then both negative conductors to the negative terminal of the NAC device. That's it. We saw earlier how the end-of-line device is wired, specifically on a Class B circuit. It's wired the exact same way as a device anywhere in the circuit. However, it only has an incoming cable. Where you would have a total of 4 conductors anywhere else in the circuit, the last end-of-line NAC device for a Class B circuit will only have 2 conductors and its end-of-line resistor. It's important to not assume, at least in an ongoing project, that because there is only 1 cable in the box, that it is the end-of-line device on the circuit. Your drawings are always your best friend in determining this, which generally, on a set of drawings, looks like this. 1 incoming cable to the last NAC device, and a symbol for its end-of-line resistor. However, NAC device wiring on a Class A circuit looks the exact same everywhere. Every NAC device has an incoming and outgoing cable. The last NAC device on a Class A circuit has its outgoing cable routed back to the panel. Here is what that would look like on a set of drawings. Out of the last NAC device, the cable goes back to the fire alarm control panel. Thank you for watching this video. Feel free to leave future video suggestions in the comments. Peace!